We're going to take a look at 30, 60, 90, and 45, 45, 90 right triangles. Quiz Thursday, December 6th on this material. Triangle similarity is going to allow me to know ratios of the sides of truly any triangle if I know the angle measures, but for most of them those numbers would be hard to remember. They would be frequently irrational numbers, or numbers that you're generating using trigonometry, at least when we're dealing with right triangles. But there's a couple that are commonly known, and you see these on the SAT test, on other standardized tests involving mathematics, and you'll see them also when you study more formal trigonometry, things like the unit circle. So it's important that you come to know these triangles, and that's why we're going to take a look at this video. The 45, 45, 90, it's how it's frequently described as the 45, 45, 90 right triangle. Okay, because it's got a 45-degree angle, a 45-degree angle, and a 90-degree angle, and I'm pretty sure you can know that. So if it's 45, 45, 90, then we also know that it's an isosceles triangle, and so I have these legs marked as congruent. And so if I were to know one leg was x, then I would know the other leg is also x, and so that leaves us with the hypotenuse. And like I said, this triangle similarity is going to allow me to learn these ratios so that I don't have to use the Pythagorean theorem each time. So if I use it once and I say x squared plus x squared equals this other side squared, okay, whatever it is, the hypotenuse, so now I have 2x squared equals that unknown side squared. I could put a variable there, but I don't really need to if I can just use my imagination here a little bit. And if I wanted to know that both of those things, then I would just take the square root. So what is the square root of 2x squared? Well, you've taken Algebra 2, and you know that when I take the square root of a number squared, I can bring it out and write it out front. Now, the principal square root, of course, we're going to use here because x needs to be a positive number. So I'm not worried at all about the negative part. The square root of 2 is the square root of 2, and so we leave it like that. And so this unknown thing is x times the square root of 2. In other words, it's the leg measure times the square root of 2. Okay, and so if I go to an example, if this is 5 feet, well then I know that this is also 5 feet, of course, because it's an isosceles, so that's kind of a gimme. And this is going to be 5 times the square root of 2 feet. Easy peasy. I mean, there's really nothing to it, right? You just have to remember 45, 45, 90, square root of 2. I remember square root of 2 because two sides are congruent to each other. The other version of this is if I've given the hypotenuse and I have to find out what are the two leg measures, or obviously just finding one of them would be sufficient. And so if I multiplied the leg by the square root of 2 to get up to the hypotenuse, then I need to do the opposite operation of multiplication, and you know that to be division. So it's 13 divided by the square root of 2. And this one also is 13 divided by the square root of 2. Okay? Now, right now, I'm not insisting on rationalizing the denominator. Okay? On the quiz, I'm not going to worry about that, but you do need to understand that on a standardized test, they will expect that you rationalize the denominator. Okay? So if I had this 13 divided by the square root of 2, I want to get the irrational number out of the denominator by multiplying the square root of 2 times the square root of 2. Then I'm going to get 2 in the denominator. I'm simplifying, so the only thing I can multiply is 1 by is 1, and so I have to do that so that that quotient is 1. And so the square root of 2 times the square root of 2 is just going to be 2, and 13 times the square root of 2 on the top. Okay, and so if you were doing this question on an SAT, that's what they would expect you to use as an answer. This would be what they would have as an option. Okay? So be aware of that. For right now, I'm not that worried about it. It's not super duper important, but you need to understand that you would be expected to do that. The other triangle we're looking at is the 30, 60, 90 right triangle, and we have a similar situation here, but the numbers are different, of course. It's a differently shaped triangle, so the ratios must be different. If it's not a congruent triangle to the 45, 45, 90, then the ratios have to be different. Okay, and if you recall, and I'm sure this is in your notes, the first thing I did when we looked at the 30, 60, 90 was I said, let's take an equilateral triangle and drop an altitude. Okay, and so when I do that, because it's an equilateral is also isosceles, okay, then I know the altitude also bisects, and so I get 30 degrees and 30 degrees. These two angles I already know to be 60 because it's equilateral. The altitude also bisects the opposite side, so those two are congruent, okay, and so that really sets me up to be able to do these ratios with the 30, 60, 90. And so now I'm going to jump and take a look back at the triangle without all that extra stuff. Okay, just this one. Okay, so I knew that the altitude bisected. Okay, and so if that's x and that's x, then, well, together that's 2x. Okay, so jump back here, 2x. And so in my 30, 60, 90 right triangle, the short leg, I know it's short because of the 30, is always half the hypotenuse. Okay, so short leg is half the length of the hypotenuse. Okay, so how do I get to then the long leg? Well, again, I'm going to use a Pythagorean theorem, but hopefully I only have to use it, this one time, and then I'll remember my ratios. Okay, and so I'm going to work over here in yellow. You can see it's a little bit different. So the Pythagorean theorem, I have the hypotenuse is 2x, so I have 2x quantity squared equals x squared. This time I am going to use a variable. I'll just call it y plus y squared, and then I'll substitute back in terms of x. 2x quantity squared on the left is 4x squared equals x squared plus y squared, and I'm solving for y now, not y squared, I'm solving for y. So now I'm going to subtract x squared from both sides, and I'll have 3x squared equals y squared. And so now I want to take the square root of both sides, so I can just get y. And similar to what we did before with the 45, 45, 90, I'm going to get x, except now it's the square root of 3 equals y. And so this value of y equals x times the square root of 3. It's the short leg times the square root of 3. Okay? And so, starting fresh, if this is x, then this is twice that, and this is x times the square root of 3. Whatever units you might have, doesn't matter. Okay? So, if, for example, this was, whoops, okay, hit the wrong button there, my apologies. If this was 7 feet, then this is 2 times 7 feet, or 14 feet for the hypotenuse. And over here, it's 7 times the square root of 3 feet. No problem. Just got to remember it. On the other hand, I might be given the hypotenuse, 16 feet. Short leg's half the hypotenuse, 8 feet. Long leg is the short leg times the square root of 3. It's not rocket science, folks. It's memorization, really, more than any other thing. And of course, we could also know the long leg. 12 inches. Okay? If I multiplied the short leg by the square root of 3 to get the long leg, then I'm going to have to divide the long leg by the square root of 3 to get back. Okay? Now, I'm going to go ahead and rationalize that. Multiply. I got 12 divided by the square root of 3, and I'm going to multiply by the square root of 3 over the square root of 3, because that will cancel to 3, or have a product of 3, I guess I should say. And then I've got 12 root 3 over 3. My really good students are going to say, oh, but Mr. Wait, that simplifies. It does. So I would get 4 square roots of 3. And that would make this 8 square roots of 3. If you didn't do that simplification or rationalize the denominator, you would have just doubled this. What's double 12 square roots of 3? What's double 12? It's 24. Excuse me, 12 over the square root of 3. So it's 24 over the square root of 3. Check on your calculator those two things, you'll find them to be exactly equal to each other. Could be mean guy. Well, I am a mean guy, and so I might give you an odd number. That would be really hard, right? 13? Oh, 6.5. 6.5 square roots of 3. Whatever units you have. You know that sometimes our tests don't include units, so just write 6.5 square roots of 3. That's it, folks. I mean, you know, these figures are going to show up in other things, right? You know, I might make it the base of a prism. Okay, and so then I could say, all right, this measure is 6 inches and this measure is 13 inches. Find the volume or the surface area or both. Right? There's not any surface area questions on the test per se, but there are area questions. So I could do that. Find the area of the triangular base, multiply by 13. Right? And so that's enough information. That type of thing. I've seen a question like this before. I've written a question like this before. Seven feet. Hypotenuse of a 45, 45, 90. How do I know it's 45, 45, 90? Well, that has to be 92. So by subtraction, that has to be 45 also. Okay, so this part is 7 over the square root of 2, which means this is 7 over the square root of 2 here. Okay, that's the short leg, so that's 14 over the square root of 2. If I was asking for that, and if I was asking for this part, that would be 7 square roots of 2 times the square root of 3, or 7 square roots of 3 over the square root of 2. Okay, totally reasonable question, right? And so if I wanted to know this whole length, it would be 7 square roots of 3 plus 7 all over the square root of 2. So there you go. You know, that's 7 on a scale of 1 to 10, maybe 6 on a scale of 1 to 10. If I gave you this and asked you to solve for this, this, and that whole thing, which is what I would do. All right, hope this is helpful.